Define f is a function in terms of x and y in two variables. In numerator x square minus y square divided by x square plus y square for all values of x and y which are not equal to 0, 0 and value of f at 0, 0 is 0. Which of the following statements are true? Option A is given to us about continuity. Option B is about boundedness. Option C is also about boundedness. And option D is about directional derivative. It means if you look option B and C carefully, then if you find one option is true, then other will be discarded automatically. And A and D option about continuity and directional derivative, it means simply if I say derivative, if function is not derivative along any path, then function is not continuous. It means it is more beneficial to test directional derivative first to test continuity, because if you test continuity first, then you will be need to test directional derivative. But if you test directional derivative first and you will find all directional derivative are not exist, then function is not continuous along that particular path. But remember one point, if f has all directional derivative at 0, 0, it doesn't mean function is continuous at that particular point. You will come across in many examples or situation when directional derivative exists at a particular point but function is not continuous. So it may be the case of that type. So if function has all directional derivative, then you will need to test, or you are bounded to test continuity at 0, 0. So I'm going to test first directional derivative. For directional derivative, many author or writer use in terms of or in direction of u, and they take u as a unit vector, and u may be any unit vector. So its component are u1, u2, and f is given to us and points are given 0, 0, point is 0, 0. So definition of directional derivative is f of 0 plus u1h plus 0 plus u2h divided by minus f at 0, 0 divided by h. If this limit exists and finite, then directional derivative exists, because we took u any unit vector. Then if this limit is exist for all values of u, then all directional derivative exist, provided this limit should be finite. So f00 is given to us 0, so no need to write here f at 0, 0. It means f u1h u2h divided by h and limit h tends to 0. Now f is given to us, f in terms of xy given to us x square minus y square divided by x square plus y square, and function f is of the kind when power sum of x and y is same throughout in numerator and denominator. It means function is of the type homogeneous linear differential equation type when we represent f in terms of x upon y. And what is the benefit of to represent function x upon y? We translate function in another coordinate system, and we can predict about some test or about function very efficiently and conveniently. So it is the benefit of this type of function when we can represent function in terms of x upon y. Also, whenever x square plus y square involve, and you look x square plus y square is given to in terms of function, always try to translate function in terms of polar coordinate, because of you can easily predict about function in polar coordinate, about boundedness and its continuity, because of many times we are unable to make graph perfectly in coordinate system. So it is many in many situations when we translate function in another coordinate system, we can easily see about something. So f limit, this limit can be written as u1 h square minus u2 h square divided by h u1 h square plus u2 h square. And if you take h square common from numerator, take h square common from numerator and denominator, then h square will be cancelled out from numerator and denominator, and h left, this h will left. So limit of this expression, whatever your u1 and u2, it means constituent of unit vector, then limit is infinite, because this expression will obtain u1 square minus u2 square divided by h u1 square plus u2 square. This type of expression you will get, and when you apply limit concept or limit h tends to 0, then this limit will be infinite, because limit is infinite here, so all directional derivative may not, so clarify is not exist here, option D is discard here. And in all direction, in unit vector or straight path, function have no directional derivative or simply derivative, it means function is not continuous along that path. It means no need to test continuity here. Now we are going to test the boundedness of this function. As I already explained you, this function can be represented in terms of x upon y. So change in polar coordinate, it can be written as f of xy, can be written as in terms of r theta. It means set x equal to r cos theta and y equal to r sin theta, and whenever you put x or y value here, then it will be r square cos square theta minus r square sin square theta divided by r square cos square theta plus r square sin square theta Take r square common from numerator and denominator, and it will be cancelled out. Left term will be cos square theta minus sin square theta divided by cos square theta plus sin square theta. In denominator, identity obtained value 1, and it is cos 2 theta. It is trigonometric function, and we know cos function is bounded, cos theta is bounded between 1 and minus 1. Because we know the graph, you can easily tell about function is bounded between 1 and minus 1. So function is bounded. Option says discard here, as I already explained in starting point. So only option B is true here. Function is not continuous. Only option B. Only option B is true here. Function is not continuous. Now consider the case when all directional derivative exist, but we need to test continuity at 0, 0. Then you should to take, because of function of the kind can be represented in terms of x upon y, set y equal to mx type. And what is the benefit? You can translate this two variable function in one variable or along this path, y equal to mx type path. function can be represented in terms of single variable, and you should need to test limit x tends to 0, and it will be, you can take x square common and left term will be 1 1 minus m square and 1 plus m square, and we will got, because this is free from x and different values of m, we will get a different limit. So function is not continuous because of definition of continuity say that if function is continuous, that it will have all limits or unique limit, all limit approaching to same number. So function is not continuous